Hello everyone, I am Disha from Sri Venkateswara College of Engineering. In this video, we are going to learn about lexical analysis. The contents covered in this video are Introduction to the lexical analysis, tokens and lexemes, working of the lexical analyzer, role of a lexical analyzer, input buffering, and specification and recognition of tokens. Lexical analysis is the first phase in the compiler design and it is also known as a scanner. It converts the high-level input languages into a sequence of tokens. Then lexical analysis can be implemented using the deterministic finite automata and the output of this lexical analyzer will be in the form of tokens which can be further sent for the syntax analysis. Let us know few points on tokens and lexeme. Token is a sequence of characters that can be treated as a unit in a programming languages. Examples of tokens are type tokens, punctuation tokens, and alphabetical tokens. Lexemes are the sequence of characters that can be matched by a pattern to form a corresponding token or a sequence of input characters that comprises a single token is called as a lexeme. Example like float and then equals to minus or any such characters or a sequence of characters. Lexical analyzer works with the several steps that involve input pre-processing. Input pre-processing means cleaning up of the input text and making it prepare for the further lexical analysis. Cleaning up of the input text involves removing the characters and white spaces and unwanted comments and all. Then the second step is tokenization. In this process, the breaking up of the input text into several tokens happen. This is usually done by matching the characters in the input text against a set of patterns or regular expressions that define the different types of tokens. The third step is token classification. In this stage, the lexer determines the type of each token. For example, in a programming language, the lexer might classify keywords, identifiers, operators, punctuation, symbols as a separate tokens. The token validation. In this stage, the lexer checks that each token is valid according to the rules of the programming language. It might check that a variable name is valid identifier or that an operator has the correct syntax. The last step is output generation. In this stage, the lexer will generate the output of the lexical analysis process, which is in the form of tokens only. These tokens can be passed to the next stage of the compilation or interpretation. Role of a lexical analyzer. A lexical analyzer will separate the characters of the source language into groups that logically belong together, which is known as tokens. It includes the token name, which is an abstract symbol that defines a type of lexical unit, and an optional attribute value called as token values. Tokens can be keywords, identifiers, operators, constants, and punctuation symbols, including commas and parentheses. A rule that represents a group of input string for which that equal token is made as an output is called the pattern. The lexical analyzer also interacts with the symbol table while passing the tokens to the parser. Input buffering is an important and a major concept in the compiler design that refers to the way in which the compiler reads the input from the source code. So input buffering is a technique that will allow a compiler to read the input in a larger format, which can improve the performance and reduce the overhead. Initially, both the pointers point to the first character of the input string as shown in the below. The forward pointer will move ahead of the string in search of the ending of the lexeme. As soon as it identifies the blank space, it recognizes it as the end of the lexeme. So, in the below example, the forward pointer encounters a white space and it will identify the int as a lexeme. Then the forward pointer will move ahead the white space. When the forward pointer encounters the white space, Next time it will ignore and moves ahead. Then both the begin pointer and forward pointer are set at next token. The input character is thus read from the secondary storage, but reading in this way is costlier. Hence, buffering technique is used. A block of data is first read into the buffer and then the second by lexical analyzer. Then there are two methods used in this context, that is one buffer scheme and two buffer scheme. Specifications of tokens involve strings and languages, operation on the languages, regular expressions. Strings and languages. A string is a finite set of alphabets and the alphabet is a finite set of symbols, and symbol can be either letters or digits and also the punctuation symbols. The length of the string can be the number of alphabets a string involves. The string is represented by using a letter S or the modulus S. Then the terms related to the string are suffix of the string, proper suffix of the string, proper prefix of the string. Then the operations on the languages are, as we learned, language is a set of strings that are constructed over some fixed alphabets. Now the operation that can be performed on the languages are union and concatenation. The regular expression is a sequence of symbols used to specify lexical patterns. A regular expression is helpful in describing the language that can be built using operators such as union, concatenation, and closure, and also the symbols. Recognition of tokens. Tokens obtained during the lexical analysis are recognized using the finite automata. So finite automata is a simple idealized machine that can be used to recognize patterns within input taken from the character set or alphabet. The primary task of a finite automata is to accept or reject the input based on whether the defined pattern occurs within the input or not. There are two notations for representing the finite automata, which are transition table and transition diagram. Transition table, it is a tabular representation that lists all the possible transactions for each state and input symbol combination. Transition diagram, it is a labeled graph and directed graph too, consisting of nodes and edges. Nodes represent the states while the edges represents the state transitions. In the above diagram, one state is labeled the start state. It is the initial state of the transition diagram where control resides when we recognize the token. Position in the transition diagram are shown using the circles and they are called as states. The states are connected by arrows and the labels on the edge are indicating the input characters. Zeros or more final states or accepting states are represented by double circle in which the tokens has been found. Then the double circle indicates that it is a final state. Thank you for watching this video. Please do like, share and subscribe.